Hello, this is Tracy. We are going to go ahead and use our TIs to calculate bivariate data. We are going to find a linear regression. We are going to find a correlation coefficient. We're going to find R squared. We're going to use our calculator to graph a scatter plot along with the regression line and also make some predictions. All right, so the data we're using is the law school candidates' prep times and test scores. In this data, we see we have three rows: the candidate, the days studied, and the score earned. Now, only two of these represent variables. The candidate, those numbers, 1, 2, 3, 4, 5, 6, 7, 8, those are just identifiers, so we know which candidate we're talking about. But that is not data to be analyzed. What we want to do is we want to look at the relationship between the number of days studied and the score earned on the bar exam. So in order to do this, we are going to, again, it's a stats class, use our favorite button, the stat button, and we're going to go right there to edit number 1. So in L1, what we want to put is the data for the variable that we think is the independent variable, the explanatory variable, the variable that we think causes the other variable. Now, sometimes it doesn't work that way. We don't have one variable that causes another, or we don't know if one variable causes the other. But in this case, I think we can have a pretty good idea that the amount of studying causes you to get a certain score. So in L1, we are going to put the data for days studied. So I'm just going to go ahead and type in that data from the table that we have. Okay, so there are the 8 students and the number of days that they studied. So in list 2, we need to put the corresponding score earned. And we have to be very careful that these match up, that the student who studied 7 days earned a score of 23. We can't mix these up, otherwise we won't be able to see if there's a relationship. So go ahead and put this data in. All right, so L1 is the independent variable, the cause, the explanatory variable. L2 is the dependent variable, the variable that we think depends on the other one, the response variable, the effect of the cause from L1. All right, so now what we want to do is we want to find all the stuff I was talking about, the regression line, the R squared, all that good stuff. So we will go back into stat. So we'll hit stat again, and we're going to perform a test. When we perform this test, it will not only give us all the information that I just said, but we'll get an indicator of whether there really is a relationship between these two variables. So scroll on over to tests. Now, none of these looks like a linear regression. So we're going to scroll down. We're going to scroll down a lot. Keep going, all the way to, there it is, F. A linear regression t-test. A linear regression, and it's going to give us the results of a test to see if we think that the relationship we see is due to chance or not. So there, F, linear regression test, hit enter. Make sure the X list is, well, wherever you put it. We put X in L1. We put the independent explanatory cause variable into list 1. And in the Y list, we have L2, where we put Y, the dependent variable, the response variable, the effect from the first list. Frequency, we're just going to leave as 1. We're not going to do anything with that. And this right here is always not equal to 0. Our hypothesis test is that there is a relationship between the two variables. The null hypothesis is that the relationship is 0. So here we're going to use not equal to 0, and then we're going to scroll down into the regression equation. We want to graph our linear equation well, not side by side, but on the same graph as the scatter plot. So we're going to store the equation of the line in a place where our calculator can go grab it to create a graph. So here in the regression equation, we're going to store that line into a variable. So go to vars. We know that we want to store it into something that we can graph. So that's the y variables. So arrow over to y vars. Function, because, well, none of the other words make any sense. So function, hit enter. And let's just go ahead and store this into y1. So on y1, we've got that highlighted. Go ahead, hit enter. So we are storing the equation of the line into y1 so we can graph it. So go ahead and go down and calculate. Now this says the form of our linear regression is y equals a plus bx. In our book, that would be y hat equals b naught plus b1x. Now when we look down, we want to look for our p-value. If that p-value is reasonably small, well, this one's tiny, 3.488, blah, blah, e to the negative 5 means go to that decimal point, that 3 point, and move it left 5 places. So our p-value is going to be 0.00003488. We're going to have 4 zeros in front there. So that is a tiny p-value, which means it's unlikely we would get this linear graph just by chance. Okay, so in here we also have our a value. Now that a value, 3.298, is our y-intercept. That's the value we get for our output variable y when our input variable x is equal to 0. When x equals 0, we get 3.298 plus, who cares what b is, we multiply it by 0. So that's what makes a equal to our y-intercept. B is equal to our slope, or our average rate of change, and b is 2.456. So the equation of the line we're going to get is y hat equals 3.298 plus 2.456 times x. Now remember, x was our input variable, our independent variable, our explanatory variable, our cause. So x is the number of days studied. We take that and we multiply it by our rate of change, 2.456, and then we add it to our y-intercept, 3.298, and that gives us our predicted score on the bar exam, because y is the score on the bar exam. All right, so that's what the equation of our line is, and that's what it tells us. So we want to scroll down to see more. Okay, we scroll down and we see R. R is 0.975778. Now remember that R is our correlation coefficient. R is a number between -1 and 1 that tells us the direction of the relationship, assuming that this is a linear relationship, and we still need to check that. We still need to graph this and make sure that we really have a linear relationship. If we don't have a linear relationship, all of this is gibberish. So we're going to graph it in a second, and it is linear. I'm going to show you that. But assuming that we have a linear relationship, what R tells us is the direction of that linear relationship. If R is positive, then we have a positive relationship between x and y. As x goes up, y goes up. As the number of days studied increases, so does the score on the bar exam. That just makes sense. The closer R is to either 1 or -1, the stronger our linear relationship is. If R is 0, that means that we don't have a correlation. Our two variables are not related. Knowing x tells us nothing about y. So R equals 0, no relationship. Knowing x tells us nothing about y. The closer r is to 1 or -1, the better we can predict y by knowing what x is. Knowing x tells us a lot about y. We can get a very good approximation to y if we just know what x is, if r is close to 1 or -1. So that's what our correlation coefficient tells us. And this tells us because 0.975778 is so close to 1 that we have a very strong relationship between x and y. We can predict y, our score on the bar exam, really well just from knowing x. Now, what r squared tells us is just how much of y we can predict from x. R squared is 0.952. That tells us that we can predict 95.2% of what you're going to get on your bar exam just by knowing the number of days studied. There's not much room for variation for other factors to come into play. In this case, we know a lot about what y is based on what x is. We know we can predict 95.2% of our score on the bar exam just from knowing the number of days studied. All right, now let's go ahead and graph the linear equation that we got here, the regression line, linear regression line of best fit with the scatter plot of the data. So what we're going to do here is we want to go to our stat plot. So see up above the y equals, it says stat plot. In my calculator on the screen, it's blue, so that's the second button. Second, y equals shows us these stat plots. Now I want to make sure that my stat plot is correctly set. So go ahead and hit enter on number 1. Now I want to turn that on, so I need to hit enter again so that on is blinking, not off. Now you got all these different types of graphs. The one we want is the first one. It looks like a scatter plot, so make sure that first one's highlighted. Make sure your independent explanatory input cause variable is in the X list, and make sure that the output, the Y variable, the dependent, the response, the effect variable is in the Y list. Pick whatever mark you like. I like blue for my color. And now we want to graph this. Now, in order to make sure that we can see both the scatter plot and the regression line, we need to zoom into the correct scale, the correct axes, the correct window. So we zoom to number 9, zoom stat. When we go to zoom stat, that tells our calculator to show us the scatter plot and the regression line. So go down to zoom stat number 9, and there it is. And look at that. We have that scatter plot that shows that beautiful linear relationship, and the line that we had our calculator calculate for us goes right through it. Our line fits the data very well. So let's go back again and talk about what we just found out. Now remember, this problem was looking at the relationship between the number of days studied and the score earned. What we have found from our calculator is that there is a strong linear relationship between the number of days studied and the score on the bar exam. This relationship is linear because we can visually see that with a graph. The relationship is strong because the correlation coefficient is 0.97 something. It's very close to 1. The relationship is positive because the correlation coefficient is greater than 0. And we can see the graph rising from left to right. That's what a positive relationship means. We are confident that we do not have a linear relationship just by chance because our p-value is so small. We have a p-value that's 0.00003 something. So a tiny p-value tells us that this strong linear relationship is not likely to be due to chance, that there truly is a relationship between the two variables. we can predict approximately 95% of the score on the bar exam just by knowing how many days we studied. We know that because r squared is approximately 0.95. We can interpret the slope of this linear equation that we found. For every additional day that we study, oh, now I can't remember it. What was our slope? Go back to tests. Boom, 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 boom. Yep. Go down, go down, go down. Calculate it. Okay. So there's our slope, B. For each additional day that we study, our score on the bar exam goes up approximately 2.5 points. That's what the slope tells us. If our input variable increases by 1, the slope tells us what happens to our output variable. If we spend 1 more day studying, we gain 2.5 points on the bar exam, approximately. If we don't study at all, no days, 0 days, if x is 0, then we can expect a score of about 3.3 on the bar exam. Not very impressive. Also, maybe not all that likely. Who knows? Okay, let's see. Was there anything else to interpret? No, I think that's the main gist of everything that we can say about the linear regression for the relationship between the number of days you study for the bar exam and your score on the bar exam. All right, as always, if you have any questions, please let me know.